Hi dear students, welcome to Brilliant Qatar. Here we are going to discuss one of the most important topic from the chapter Chemical Bonding and Molecular Structure, that is hybridization. So what is mean by hybridization? How to calculate hybridization in a shortcut method and how to answer the hybridization calculation steps to answer 3-mark question. So everything in detail with a simplified manner we can discuss in this session. So dear all, hybridization, chapter Chemical Bonding and Molecular Structure. First of all, what is mean by hybridization? You know the atomic orbitals, right? Atoms having orbital like s orbital, p orbital, d orbital, f orbital, right? You know, s orbital, we have only one type. There is no different types of s orbital, right? Sx, Sy, like a px, py. No, there's only one type of s orbital. We will write only one orbital. Am I right? You may study the Aufbau principle, Hund's rule, and how to fill the electrons and all. What about p orbital? You know, p orbital while you're drawing, any p orbital while you're drawing, you will write 3 orbitals. Which all are they? Px, py and pz. You may study it in Structure of Atom chapter. And d orbital while you're writing, you will write 5 orbitals, right? 5 orbitals. Which all are the 5 orbital? dxy, dyz, dxz, dx square minus y square and dz square. These are the d orbital. So s orbital 1, p orbital 3, d orbital 5 are there. This mixing of these orbital, which orbital? Atomic orbitals are known as what? Hybridization. But we can't mix a random order. S we can't mix with a D because their energies are larger difference. Right. So what is mean by hybridization? Mean it is the process of intermixing of atomic orbital. What all atomic orbital? S, P, D, F, like that, with the same energy levels. You can't mix different orbitals in random order. While you mixing the orbital, what you have to consider? Almost they should have a same energy. So those atomic orbitals having almost the same energy while you mixing, it will give the same number of new type of orbitals are called hybrid orbitals. So simply we can able to say hybridization is a process of intermixing of atomic orbitals having almost a similar or there should be only a slight difference in energy. Okay, there should not be a large difference in energy. So atomic orbitals having almost a similar energy, while you mixing, you will get equal number of new orbitals. They are called what? Hybrid orbitals. This process is called hybridization. Now, what are the characteristics of hybridization? 1. Atomic orbitals with equal energies undergo hybridization. As I told you, there should not be a S we can't directly mix with a D orbital because there is a larger difference. Okay, so only the atomic orbitals having similar energy, almost similar energy, that orbital only we can mix it for hybridization. Second, the number of hybrid orbital formed is equal to the number of atomic orbital mixed. How many atomic orbitals you mix it? For example, you mixed one s orbital with one p orbital. Hybridization is sp. You mix the 2 orbitals, right? sp, right? S and p. So if you mix 2 atomic orbital, you will get 2 hybrid orbital. Similarly, if you are mixing one s orbital with this 2p orbital, so what is hybridization? sp2. One s orbital with 2p orbital, sp2. So total atomic, how many atomic orbitals you mixed? 3. So therefore therefore 3 hybrid orbital can form. If you want 4 orbital to mix dear all, s and then remaining 3 p orbital. So sp3. How to write? sp3. Total how many orbitals are there? 4 are there. So 4 atomic orbits if you are mixing, there should be 4 hybrid orbital can form. Similarly, if you want total 5 orbital to mix, so once again, if you want to mix 2 orbital, which all to mix? S and P, sp. If you want to mix 3 orbital, sp2. If you want to mix 4, sp3. Can we write sp4? No, because only 3 orbital p orbitals are there. So s, if you want to mix overall 5 orbital, sp3d. If you want to mix total 6, sp3d2. because we have d5 orbitals, right? So sp3d3, like that hybridization goes on. So how many atomic orbitals you are mixing, equal amount of hybrid orbitals can form. That's it. Now next one, hybridization happen only during bond formation, not in the isolated gaseous atom. They're all hybridization, mixing of atomic orbitals can happen only when atoms combine to form molecules. It is not possible in their individual state. That is only atomic orbitals. If nitrogen atom means it's having some atomic orbital, it can't mix. When nitrogen combine with other element, or for example nitrogen combine with one another nitrogen, then only this what mixing of atomic orbitals can form. Only during bond formation this mixing can be possible, not in their individual stage. Then what is one more? The shape of the molecule can be determined if you know the hybridization. You already know how to calculate the shape of the molecule by using VSE PR theory, right? But through hybridization, if you know the hybridization of a molecule, you can able to say what is the shape of the molecule. So this is what hybridization definition and their characteristics. Now let us enter into the topic. Dear all, if you know the hybridization, as I told you, you can able to say the shape of the molecule. Basically, we are dealing with these 5 hybridization in our questions discussion. So what are the hybridization, dear all? sp, sp2, sp3, sp3d and sp3d2. These are the main 5 hybridization we are going to discuss. Once again, dear all, sp, sp2, sp3, sp3d and sp3d2. If you know the hybridization, structure is ready. If it is sp, structure is linear shape. If it is sp2, trigonal planar shape, you know, linear shape, trigonal planar shape. If it is sp3, tetrahedral shape, tetrahedral shape. If it is sp3d, trigonal bipyramidal. What is trigonal bipyramidal? Trigonal, you know, triangle, one pyramid above and one pyramid below. Trigonal bipyramidal. What about sp3d2? Octahedral. That is what? Square bipyramidal. These are the hybridization mostly you can expect for your examination and the corresponding shape. All of you just stop, pause the video and study the table, then continue. Right. Now we can start the questions for your examination. Any 1 or 2 question from this discussion is sure for your examination. So carefully mark it and notice. Find the hybridization of carbon in CH4. You know, CH4 is called what? Methane, right? Let me draw a small Lewis structure of this compound, okay? What is CH4? Carbon. Carbon, you know, valence electron is what? 4. It is surrounded by 4 hydrogen atom. You know, hydrogen valence electron is 1. So they will form covalent bond. They completed, carbon completes octet. This is the normal Lewis, you know, representation, the bond formation in methane, you know that. Total, how many sigma bonds are there? You know, each single bonds are what? Sigma bonds, right? Okay. This is the normal structure of which one? Methane. Ready, dear all? Shall we start the hybridization? How to calculate? In order to calculate hybridization, total we need 3 steps. Basically, it is a 2 to 3 mark question. So, steps are very clear. We have to write it very proper manner. Okay, let's go for step number 1. What you have to do in step number 1? In step 1, you have to write the ground state. You have to write the ground state of the element. They are asking what is hybridization of the carbon. Basically, we are calculating the hybridization of the central atom. Who is the central atom in this one? Carbon is the central atom. Okay. So, what is the ground state of carbon? Ground state means what? The normal, right? So, carbon, you know, carbon atomic number is what? 6. Carbon atomic number 6. What is the configuration? 1s2, 2s2, 2p2. Am I right? This is the ground state, normal stage configuration of which one? Carbon. Let me write. What is 2s? I'm not writing complete orbitals in orbitals, the boxes, right? Because only the outermost electron, you know, take part in bonding and all. So, all orbital no need to express, only the last 2 orbital try to express. What is 2s2? 2s orbital contain 2 electron. What is 2p? You know, p orbitals we have 3 in which 2 electron means 1, 2. Okay, this is the ground state diagram of which one? Carbon. Now we are going for step 2. what you have to do on step 2? Dear all, sometime the step needed excited state, sometime not. So how to identify whether excited state is required or not? Okay, very simple. Dear all, on the central atom carbon, total how many bonds are there? Total there are 4 bonds. Am I right? 1, 2, 3, 4. If there are total 4 bonds, you make 4 unpaired electron in the atom. What is the once again? In step 2, we are checking whether excited state is required or not. Okay. Carbon, total how many bonds are there? Total there are 4 bonds. 4 bond means 4 unpaired electrons should be there. In ground state, do you have 4 unpaired electron? No, you have only 2 unpaired electron. How you can make it 4? Excite 1 electron from 2s to 2p. So excited state is required. So from 2s, 1 electron we transferred. Then we have 2p, the total 3 electrons now. Now do you have 4 unpaired electron? Once again, how you make a 4 unpaired electron? How to check? On this carbon, total how many bonds are there? Total there are 4 bonds. That means 4 unpaired electrons should be there. So 4 unpaired electrons we did by exciting 1 electron. Okay, dear all, let me go for the last step, step 3. Step 3 is the hybridization calculation method. Dear all, hybridization is calculated by the sum of sigma bond and lone pair on the central atom. On the atom which you consider, hybridization is calculated by the sum of sigma bond and lone pair on the atom. On this carbon, total how many sigma bond? 1, 2, 3, 4. Yes, okay, 4 sigma bonds. How many lone pair on this carbon? No lone pair, right? 0. So what is the total sum? 4. As I told you, if the total sum is 2, if you want to mix 2 orbital, sp. If you want to mix 3 orbital, sp2. If you want to mix 4 orbital, sp3. So 4 mean what is the hybridization? sp3. How it's getting? I'm just rewriting this one, dear all. This is what? 2s. This is what? 2p. Alright, each 1 electrons are there. So total, how to calculate hybridization? Once again, carefully focus. Hybridization is calculated by the sum of what? Sigma bond and lone pair. How many sigma bond on carbon? 4. How many lone pair? 0. Total 4 mean sp3. So sp3, which all mix these all s, 1 s orbital and 3 p orbital. sp3. sp3 means we already know what is the shape. If the hybridization is sp3, structure is tetrahedral. So what is the shape of methane molecule? Tetrahedral. Okay. Once again, dear all, how to calculate hybridization through the 3 steps. Step 1, you should write the ground state of the atom, normal. Second step, you have to consider the excited state. How to check whether excited state is required or not. Total how many bonds on the atom? Equal amount of unpaired electron you have to make. So we made unpaired electron by exciting 1 electron. Step 3 is hybridization. Hybridization is calculated by the sum of sigma bond and lone pair. If the sum is 2, sp hybridization. If it is 3, sp2. If it is 4, sp3. If it is 5, sp3d. If it is 6, sp3d2. Like that, you have to consider the hybridization. For corresponding hybridization, we have a corresponding shape also, tetrahedra. Now, we are going to say how this molecule is forming. Dear all, we are going to draw the orbital overlap diagram for methane. Carbon is the central atom. You already know the shape of the molecule is what? Tetrahedral. You know, tetrahedral shape, this format. Tetrahedral, right? We discussed in hybridization the first point, what are the characteristics of hybridization. How many atomic orbitals you are mixing, equal amount of hybrid orbital form. Once again, how many atomic orbitals you are mixing, equal amount of hybrid orbital form. How many atomic orbital you mixed? 1, 2, 3, 4. 4 atomic orbital. Therefore, we got sp3, right? 4 atomic orbital you mixed mean 4 hybrid orbital form. Which is the hybrid orbital? sp3. So, 4 atomic orbital if you mixed, you get 4 sp3 hybrid orbital. And maintain the structure tetrahedral and draw it. How to draw that one? 1, 2, 3 and 4. Actually, sp3 orbitals while you drawing, we have to draw this way. But if you write all those lobes up and down, it will be totally complicating. So I'm writing only one part. Otherwise, you can do this lobe, its end is here. This lobe, its other part is here. This lobe is here. This lobe is here. Like that you can draw it. So if you write all the lobes, it will be totally confusing. So therefore, only one lobe which is needed to make a bond with the other element, here which is the other element hydrogen, that orbital only you have to enlarge. Okay, so why we draw 4 orbitals here? Can you guess it? Because 4 sp3 orbitals formed here, because you mixed 4 atomic orbitals. What are these 4, dear all? These all are the sp3, 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 sp3 hybrid orbital of carbon. That contain, each orbital contain 1 electron, right? So they contain 1 electron each. Okay. Carbon ready. What about hydrogen? You know, hydrogen configuration is what? 1s1. So it is coming with the s orbital, 1 electron. So hydrogen come with s orbital, it gives its 1 electron, they form a bond. Hydrogen come with its 1 electron, they made a bond. Similarly, total 4 hydrogen, they form, you know, s orbital and p orbital. When they make a head-to-head overlap, you will get a sigma bond. So these are the 4 sigma bond created by carbon and hydrogen, in which one? The chemical bonding formation. So this is the way you have to explain the hybridization of carbon in methane. Dear all, keep focus on the video. We are discussing more complicated and more different type of compound in this video. Second one. So this is the shape of which one? Methane. Okay, sp3, 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 4 sp3 of carbon and 1s of which one? Hydrogen. They contribute 1 electron and they form bonds. Head-to-head overlap form sigma bond. And you know, as I told you, when you represent all the lobes like this one, it will be totally complicating. So when you're drawing an sp3, sp, sp2 orbitals and all, write only one lobe in enlarged one, other one write a small one. Can you able to see that one? To avoid mistakes and complication, we can just write it as the other lobe, a small one. Okay. Let us discuss, find the hybridization of carbon in ethene. What is ethene? Ethene is CH2 double bond CH2. Let me write this complete bonding. You know, CH2 double bond CH2. This is the complete bonding. We are going to calculate the hybridization of any one of the carbon. Okay, because both of the carbons are in the same environment. So one of the carbon, I am going to calculate the hybridization of this carbon, this marked carbon. It will be the same for the other carbon. On this carbon, total how many sigma bond here all? You know, this is sigma, 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 and this is pi. What about this carbon? The sigma and sigma. Okay, as I told you, I am going to calculate, or we are going to calculate the hybridization of only the marked carbon. Okay, so you focus on only on this carbon. Start. What is step 1? Step 1 is writing the ground state of that atom. Carbon atomic number 6. So configuration 1s2, 2s2, 2p2. Let me write the orbital 2s2 electron, 2p 2 electron. Okay, what is step 2? In step 2 we are doing an excited state. Whether excited state is required or not, how to calculate? On this carbon, total how many bond? Total there are 1, 2, 3, 4. Total there are 4 bond. If there are 4 bond, there should be 4 unpaired electron. Do you have 4 unpaired electron in ground state? No, only 2, right? So excite. So excite 1 electron. So what is excited state here all? 2s, now 1 electron, 2p, there are 3 electron. Okay, ready. 2s and 2p ready. Now 4 unpaired electron. Excited state we did. What is step 3? Hope you remember step 3 is the calculation of hybridization. Hybridization is calculated by the equation. Which one? Sum of sigma bond and lone pair. Hybridization is calculated by the sum of sigma bond and lone pair. How many sigma bond on this carbon? Don't count the overall sigma bond, okay? Only on that carbon. How many sigma bond on this carbon? 1, 2, 3. 3 sigma bond plus. Is there any lone pair on carbon? No. So what is the total sum? 3. If the total sum is 3, what is hybridization? sp2. sp2. Right. So sp2. So how to mix dear all this orbital? This is the 2s. and this is the 2p orbital. Each 1 electrons are there. How they form a bond? sp2 mean this s and p2. S and p2, one s orbital and 2p orbitals overlap. sp2 hybridization means structure you may study trigonal planar. sp2 mean trigonal planar. So when you drawing the shape of this molecule, when you writing the overlap diagram, you maintain the structure trigonal planar and draw it once again. Carbon. Okay, this carbon. What is the structure? Trigonal planar. Okay. How many sp2 orbitals are formed? Can you say? We know how many atomic orbitals are mixing. Equal amount of hybrid orbital form. How many atomic orbitals are mixing? 1, 2, 3. These 3 you mixed. So 3 atomic orbital mixed mean 3 sp2 will form. 3 sp2. 3 orbital maintain the structure trigonal planar. How to draw it? 1, 2, 3. Have you seen trigonal planar? When you write in the other law, we can write like this. This one, and this one. Okay. Now, what about the other carbon? There is one more carbon, right? Even the I told you what all things we are doing for this carbon, same for the other carbon. So that is the other carbon. It also having this 3 orbital. It is also maintaining the structure what? Trigonal planar. So what is this hybrid orbital? sp2, and this is sp2, sp2. These are the 3 sp2 orbital of one carbon, and you know they contain 1 electron each. What about this carbon? This is the sp2, sp2, sp2 of this carbon, and that also contain 1 electron. Have you seen this carbon already made a head-to-head overlap, axial overlap. They form a carbon-carbon sigma bond. So carbon-carbon sigma bond, pakka, ready. What about the other? Have you seen that here all? In other case, what about on this carbon? You may notice there 2 hydrogens are there. Yes or no? Hydrogen which orbital? 1s orbital. So hydrogen is coming with 1 electron. They made a sigma bond. Hydrogen is the other hydrogen, 1 electron shared, another sigma bond. So carbon hydrogen sigma bond over. The same way this hydrogen also come with what? 1 electron, and this hydrogen also come with 1 electron. This hydrogen also come with 1 electron, and they form a bond. These all are what? Sigma bond. So this is also okay. Have you noticed carbon-carbon sigma bond formed? Carbon-hydrogen sigma bond also formed. Have you noticed that one pi bond is left over between carbon and carbon? How the pi bond is forming? You may study pi bond is formed by the overlap between 2 p orbitals, right? It may be p or d. You may study 2 p orbitals when overlap sidewise. Sidewise, you will get 1 pi bond. Where is that p orbital? Where is that p orbital? Have you noticed this p orbital we didn't include it in the hybridization. So 1 p orbital is free on 1 carbon. So 1 carbon carry 1 p orbital. Same way the other carbon carry 1 p orbital. These 2 p orbitals makes a sidewise overlap. A sidewise overlap, you will get 1 pi bond. So this is the way the compound CH2CH2 is formed. The given explanation is based on hybridization. Hope it's clear here all. The most important. So this is the one, okay. So carbon, trigonal planar, and hydrogen sigma bond. These are the p orbital on carbon. They make sidewise overlap and they form pi bond. The orbital overlap diagram is very important. The another compound is ethyne. What is ethyne? CH triple bond CH, or C2H2 is called ethyne. Let me write the correct bonding. Okay, CH triple bond CH. This is the bonding. I'm going to calculate the hybridization of only this carbon. It will be same for this carbon. How many bonds here all? Here CH sigma bond. This is sigma. In a triple bond, 1 sigma and 2 pi. This is again sigma. Okay, I'm going to calculate the hybridization only on this carbon. Okay, let's start here all. What is step 1? Step 1 is simple. Carbon is our element. Atomic number 6. So 1s2, 2s2, 2p2 is the configuration. 2s contain 2 electron, 2p contain 2 electron. Okay, ready? Step 2. Whether excited state is required or not. How to check dear all? Total how many bond on this carbon? 1, 2, 3, 4. If there are 4 bonds, there should be 4 unpaired electron. Yes, we have to excite 1 electron. So what is the orbital? Here 1 electron. Here now we have 3 total. Yes, 4 unpaired electrons are ready. Let's go for the last step, step 3. Step 3 is the hybridization calculation. Hybridization is given by the sum of sigma bond and lone pair on the central atom. Here carbon is the atom we are considering. Total how many sigma bond on carbon? 1, 2, right? 2. Is there any lone pair? No. Total sum is 2. Total sum is 2 mean I told you SP is the hybridization. How to get SP, dear all? Let me write 2s again, 2p again. Alright. So 2s orbital, sp, right? S and p orbital mix. This is s and this is 1p. So sp orbital. Hope you see that 2p orbitals are free there. You know, sp hybridization mean structure is what, dear all? Linear shape. Yes. So by maintaining the shape, let's draw the diagram. Okay. Ready? Here also we have 2 orbitals. So 2 sp orbitals. So what all things we are doing for the one carbon, same for other carbon. So this carbon also carry those 2 orbitals. So what is the hybridization of this carbon, this 2 orbital? These are the sp orbital of this carbon and these are the sp orbital of the other carbon. And you know, they carry 2 electrons. So 1, 1. Even this carbon, 1, 1. Okay. This carbon already they form sigma bond. Okay. What is the use of this orbital, dear all? This orbital need to make a bond with hydrogen. You know, hydrogen come with what orbital? S orbital with 1 electron. Yes, they make a bond. It's a head-to-head overlap, sigma bond. Even this case also hydrogen form a sigma bond by making 1 electron head-to-head overlap. Carbon, sigma bond, okay. Carbon, hydrogen, sigma bond, okay. Hope you notice that there are 2 pi bond left over this carbon, right? So how they form this carbon-carbon pi bond? Dear all, on each carbon, 2 p orbitals are free. 2p, or this p orbital we didn't included in the, which one? The hybridization, right? So this on one carbon, 2 p orbitals are free. Let me draw 1 p orbital, this, the other p orbital. The other p orbital is this. So on each carbon, 2 p orbitals are free, right? So this is one of the p orbital of carbon and this is the other p orbital. Okay. Now what about the other carbon? Same situation will be there. So this is the p orbital of 1 p orbital of the other carbon and the second p orbital of carbon. And how they form a bond? You know, p orbital is formed by the sidewise overlapping, right? So the pi bond, the pi bonds are formed by the sidewise overlapping of p orbitals. So these yellow colored, that's a p orbital, they overlap sidewise, you will get 1 pi bond. What about other? The white colored, these 2 get overlap sidewise, you will get another pi bond. So this is the way you can explain the complete bonding in ethyne. See the video. So dear all, this is the carbon, linear sp orbital, 2. And this is the other carbon, linear sp orbital. This is the hydrogen, they make bonding. This is sigma, sigma, sigma. And these are the 2p orbital of one carbon, 2p orbital of other carbon. These 2 form sigma pi bond, these 2 form pi bond. This is the way ethyne molecules are forming. Now some special cases we can discuss. Find the hybridization. Now the 3 questions we discuss all are carbon compounds, right? Now let us discuss one other. Find the hybridization of phosphorus in PCl5. Dear all, phosphorus, you know, atomic number of phosphorus is 15. So the configuration of phosphorus is 2, 8, 5. So 5 is the valence electron of phosphorus. So phosphorus 5 valence electron, it is surrounded by 5 chlorine atom. You know, chlorine valence electron is 7. So they need 1 more electrons to complete their octet. So they will share from phosphorus. So hope you notice that this is the way phosphorus making bond, right? The shape and all, you already know that through VSE PR theory. But if they ask question with the hybridization, we can't able to use VSE PR. We have to explain through hybridization, right? Okay, let's start here all. Hope you know these all are what? Sigma bonds. Okay, let's start step number 1. What is step number 1? Write the ground state of the central atom. Who is the central atom? Phosphorus. You know, phosphorus atomic number 15. Configuration is 1s2, 2s2, 2p6, 3s2 and 3p3 is the ground state configuration. Let me draw the 3s orbital 2 here and 3p orbital 3 here. All right. And step 2 is required or not. How to check step 2 required or not, dear all? On phosphorus, total how many bonds are there? Total there are 5 bonds. If total there are 5 bonds, they should have 5 unpaired electrons. Do you have 5 unpaired electrons in ground state? No, you have only 3, right? 1, 2, 3. So we have to excite. So how to excite electron? 3s, 3p already unpaired electrons are there. After 3p, which is free, 3d is free. You know, while you filling electron, you may go to 4s. You know, after 3s2, 3p, 6 and then you will go to 4s. That is filling of electron order of Bohr rule. But here we are exciting electron to the next level. After 3p, the next level is 3d. So from 3s, let me excite 1 electrons to what? 3d. How to write that one? This 3s. Okay, let me draw here. The 3s, now 1 electron. 3p, that's already carry 3 unpaired electron. Now 3d is there. That excited 1 electron. Now you see 1, 2, 3, 4, 5 unpaired electrons are there. Let's go for step number 3. What is step 3? Step 3 is what? Hybridization. Hybridization is calculated by the sum of sigma bond and lone pair. How many sigma bond on phosphorus? 5. Is there any lone pair? No. So total is 5. Total 5. Let me draw this diagram. Orbital once again. 3s is there, 3p is there and 3d is there. All right. Total sum is 5. 5 means which all orbital you have to mix? sp3d, right? sp3d, mix it. How many atomic orbital you are mixing? 1, 2, 3, 4, 5. 5 atomic orbital mixing mean 5 sp3d orbitals will form. sp3d mean we know what is the shape. The shape is what? Trigonal, bipyramidal. Trigonal, bipyramidal. So dear all, we are going to draw the orbital overlap diagram. Maintain the structure trigonal, bipyramidal. Central atom is phosphorus, right? 5 sp3d orbital will form because you mixed 5 atomic orbital. Maintain the shape trigonal, bipyramidal. 1, 2, 3. What is this? Trigonal. Bipyramidal means 1 up, 1 down. Its corresponding other part will be there. Okay, other lobe will be there. I'm just not writing and complicating that structure. So this is 1 and this is 2nd, this is 3rd, this is 4th, this is what? 5th. For each orbital, its corresponding other lobe we have to consider. Okay, so this is about phosphorus. And what about? So what are these 5? These all are sp3d, sp3d orbitals of which one? Phosphorus. sp3d, 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 5 orbitals of which one? Phosphorus. You know, each of them contain 1 electron. So let me express 1, 2, 3, 4, 5. Okay, 5 electrons are there. Here the phosphorus is connected to. Here the phosphorus is connected to which element? Chlorine. In all other previous cases we considered hydrogen. Here the surrounded element is which one? Chlorine. You know, chlorine, which is the outermost, chlorine atomic number 17, configuration is 1s2, 2s2, 2p6, 3s2, 3p5. See, its outermost orbital is which orbital? P orbital, not s orbital. So chlorine is coming with the outermost p orbital. You know, p orbital we can express like this, and they have to make a head-to-head overlap. So these are the p orbital of which one? Chlorine, right? And chlorine also contribute 1 electron each to form a bond in between. So these are the sigma bond formed in between. So this is the way they form a compound trigonal. You know, this is what we call trigonal bipyramidal shape. Let's see one another question. SF6. So this is the one, okay, force PCl5, this is the shape. Next one, SF6, sulfur. You know, sulfur is the central atom. Sulfur valence electron is what? 6. You know, sulfur atomic number 16, right? Sulfur atomic number, step 1 we can write sulfur atomic number 16. So the configuration is 1s2, 2s2, 2p6, 3s2 and 3p4. So how to mark it here all? This is 3s, 2 electron. This is 3p. It's having 4 electron. 1, 2, 3, 4. All right. So s orbital, the SS sulfur atom, this is the ground state. And sulfur 6 valence electron, it is surrounded by which element? 6 fluorine atom. You know, fluorine need 1 more electrons to complete their octet, right? It's a halogen. Halogen 7 electron in their valence shell, need 1 more electrons to complete their octet. Okay, done. Total how many sigma bond? 1, 2, 3, 4, 5, 6 sigma bonds are there. Okay, let's make the hybridization. Ground state, okay. 3s and 3p, okay. Step 2, check it all of you, whether excited state is required or not. Total how many bonds on sulfur? 1, 2, 3, 4, 5, 6. Total there are 6 bonds, so there should be 6 unpaired electron. Now you have only 2 unpaired electron. How you can make 6? Excite 1 electron from 3p to 3d, excite 1 electron from 3s to 3d. So what is the orbital you will get? 3s is there, 3p is there, and we have 3d, right? 3d. So 1 electron loose, so remaining 1 electron. 3p already 3 and this 1 more electron we excited, right? So generally this 2 electron we excited into 3d. Now you have 1, 2, 3, 4, 5, 6. 6 unpaired electrons are ready. Now let's go for the last step. Step 3 is the hybridization. You know, hybridization is given by the sum of sigma bond and lone pair. Total how many sigma bond? 6. No lone pair. Total sum is 6. Right? Total sum is 6. This is 3s and this is 3p and this is what? 3d. Okay, these having 1 electron each. They're all hybridization, what it can be. Total you have to mix 6 orbital. 6 orbital while you mixing. What is hybridization? sp3d2. So mix these all sp3d2. If the hybridization is sp3d2, structure we studied as what? Octahedral shape. What is octahedral shape? Square bipyramidal. How to draw here all? Sulfur. What is octahedral? You know, total 6 atomic orbital you mixed, right? So total 6 atomic orbital mixed mean 6 hybrid orbital form. What is hybrid orbital? sp3d2. So 1, 2, 3, 4, 5 and 6. These are the sp3d orbital of sulfur. And what is the surrounded element? The surrounded element is fluorine. Fluorine atomic number is 9. So configuration 1s2, 2s2, 2p, 5. So its outermost orbital is p orbital. So fluorine is coming with p orbital. It make a side a head-to-head overlap to form what? A sigma bond between sulfur. So dear all, these all are fluorine orbitals, p orbital, and this is the way they form head-to-head overlap, form which bond? Sigma bond. This is the way they are going to form which one? Square bipyramidal, that's octahedral shape for the molecule SF6. We have 2 special cases to deal. So this is the SF6 molecule formation. Okay. Next one. There are some special cases we have to deal in this topic. It's a very clear question for your exam. Find the hybridization of nitrogen in NH3. You know, nitrogen valence electron is 5. It is surrounded by 3 hydrogen atom. You know, hydrogen valence electron is also 1. So they will share electron like this. You can able to see there are 3 sigma bond and 1 lone pair on nitrogen. Okay, dear all, let's start. What is step 1? Step 1 is the ground state of nitrogen. Nitrogen atomic number 7. So configuration 1s2, 2s2 and 2p3. Right. So 2s orbital contain 2 electron, 2p orbital contain what? 3 electron. Okay. Whether excited state is required or not. Can you guess it? They're all nitrogen here. Total how many bonds are there? Total 1, 2, 3. Total there are 3 bonds. If there are total 3 bonds, there should be 3 unpaired electron. I think in ground state itself you have 3 unpaired electrons. So no need to excite. Directly we can go to step 3. What is step 3? Hybridization. You know, hybridization is given by the sum of sigma bond and lone pair. Total, how many sigma bond on nitrogen? 1, 2, 3. How many lone pair? 1. Total is what? 4. 4 means, what is the hybridization we studied? sp3. So hybridization is what? sp3. So let me draw the diagram once again. This is 2s and this is what? 2p. All right. So 2s here 2 electron, here 1 electron each. What is hybridization we said? sp3. Yes. sp3 mean, what is the shape? We studied that tetrahedral shape, right? Tetrahedral. What is tetrahedral pattern? This is tetrahedral. How to draw it? Nitrogen is the central atom. Okay. You know, 4 atomic orbital mixed mean 4 hybrid orbital form, right? 4 sp3 form. How to write in tetrahedral? 1, 2, 3 and 4. Correct. One of the orbital contain 2 electron. Okay, 2 electron. The other 3 orbital contain 1 electron each. Can you guess it? What is the use of these 3 orbital? To form bond with what? Hydrogen. You know, hydrogen coming with s orbital, 1 electron, they form sigma bond. The other hydrogen shared 1 electron, sigma bond. The other hydrogen, 1 electron, sigma bond. So nitrogen and hydrogen, sigma bond, everything perfect. Then what is the use of this one? What is this? This is the 2 electron. See that already 2 electron that not involved in bonding, what we call it as lone pair, right? This is the lone pair on this nitrogen. This is actually tetrahedral shape, but we may study that the shape of this ammonia molecule is what? Like a trigonal pyramidal shape, right? Trigonal pyramidal. You know, tetrahedral, you know, because of this lone pair, bond pair repulsion. According to VSE PR theory, lone pair bond pair repulsion is little big. So because of lone pair bond pair repulsion, it can't stable in the tetrahedral shape. So because of this repulsion, this shape is called distorted tetrahedral. Distorted tetrahedral. Almost we can able to say it can't exist in tetrahedral shape. It get disturbed because of the lone pair bond pair repulsion. So it comes to the shape of ammonia. Correct shape what we studied. Trigonal pyramidal shape. Trigonal pyramidal. So ammonia shape we can call it as what? Trigonal pyramidal, or we can call it as what? Distorted tetrahedral. Let me give you one more example for that. This is the way, okay? So 3 hydrogen form sigma bond. This is the 1 lone pair. Now, what about H2O, oxygen? Oxygen, you know, valence electron is what? 6 valence electron surrounded by 2 hydrogen atom. You know, each hydrogen need 1 electron. So total there are 2 sigma bond and 2 lone pair. Okay, let's start. What is step 1? Step 1 is oxygen electronic configuration. 1s2, 2s2 and 2p4. Let's draw 2s here 2 electron, 2p contain 4 electron. 1, 2, 3, 4. Okay. Whether excited state is required or not. Check. Total how many bond on oxygen? 2 bond. If there are total 2 bond, there should be 2 unpaired electron. I think in ground state itself, you have 2 unpaired electron. So no need to go for excited state. Directly go to step 3, hybridization. You know, hybridization is given by the sum of sigma bond and lone pair. How many sigma bond on oxygen? 2 sigma bond. How many lone pair? 2 lone pair. So total is what? 4. 4 means what is hybridization again? sp3. Right? sp3. How to write this one? This is, you know, 2s orbital and this is what? 2p orbital. Okay. Right. So sp3 mean we have to mix s and this 3p. So sp3. How many atomic orbitals you are mixing? Equal amount hybrid orbital form. So 4 sp3 orbital form because you mixed 4 atomic orbitals, right? So maintain the structure. You know, sp3 mean what is the shape? Tetrahedral shape. So maintain the shape tetrahedral. Draw the diagram. Oxygen. Total how many orbitals you are mixing? 4 orbitals. So 4 sp3 will form. So 1, 2, 3 and 4. Okay. How many electrons here all? One orbital having 2 electron. Other orbital having 2 electron. Other 2 orbitals have 1 electron. Okay. Which is the attacking element? Hydrogen, right? So hydrogens comes with 1 electron, they form a sigma bond. The other hydrogen, they form 1 electron, sigma bond. Okay. So oxygen, hydrogen, sigma bond. Okay. So what is these two? These two are the lone pairs on oxygen. See, these are the two lone pairs. You know, according to VSE PR theory, lone pair repulsions are too high, right? According to VSE PR theory, lone pair repulsion is too high. So it mostly cannot exist in the tetrahedral pattern. So it is also called what? Distorted tetrahedral. And oxygen shape, you may study that. It comes to bend shape, right? It comes to bend shape. So ammonia and water, careful here all, ammonia and water case, they are actually in sp3 hybridization. As per sp3 hybridization, its structure is what? Tetrahedral. But you know, ammonia not in tetrahedral, it is also called distorted tetrahedral and come to what shape? Trigonal pyramidal shape, right? Ammonia comes to what? Trigonal pyramidal shape. Whereas in water also you are getting sp3 hybridization and it's actually what? Tetrahedral shape, but it is coming to what? Bend shape due to what? The lone pair repulsion. So ammonia and water is also known as in the form which one? Distorted tetrahedral. So these are the different type of which one? Hybridizations and their calculation. And one question, find the hybridization of each carbon in the following compound. In a short way, how to calculate hybridization? As I told you, hybridization is calculated by the sum of sigma bond and lone pair, right? Let me just expand this compound. What do you mean by CH2? This is what? CH2, double bond, CH, single bond. You know, carbon and nitrogen form triple bond, right? What is the hybridization of each carbon? Can you tell me, dear all? In a short way, how to calculate hybridization? Hybridization is calculated by the sum of sigma bond and lone pair, right? Tell me, on this carbon, how many sigma bond? 1, 2, 3. This is pi, right? So total 3 sigma bond, no lone pair. 3 means what is hybridization? sp2. Okay, so this carbon sp2. What about this carbon? Total how many sigma bond? 1, 2, 3. 3 sigma bond and no lone pair. 3 means again sp2. What about this carbon? 1, you know, this is sigma and pi. Total how many sigma bond? 2 sigma bond. 2 means what? sp. So this way, while calculating the sigma bond and lone pair on the atom, you can say the hybridization directly. This method you can use it only for MCQ question. Previous step 1, step 2, step 3 used for your descriptive type 3-mark questions and all. Step 1 ground state, step 2 excited state, step 3 what? Hybridization. And practice the orbital overlap diagram, how to draw it all. So hope you clear the entire idea about hybridization and how to calculate what is mean by hybridization, what are the characteristics of hybridization, and how to calculate hybridization through step 1, step 2, step 3, and in shortcut method and the orbital overlap diagram. These are the questions from hybridization part. Let's discuss some other topics in the upcoming videos. Hope you understand this concept. Thank you all. See you soon.